let's find out how to get the roots of a quadratic equation by using which method? By completing the square. Now if you look at the board, I have written a problem x square plus x minus 20 which is equal to 0. The first thing, children, that you have to take care is, in this method, the coefficient of the square term should be equal to 1. So over here you can see what is the coefficient of the square term? It is equal to 1. So let's proceed now with the next step. In the next step, that is the first step towards solving the problem, the constant term, you can take it on the right hand side. So minus 20, when it goes on the other side, negative becomes positive. So x square plus x is equal to 0 plus 20. So here we get x square plus x, which is equal to 20. Now if you look at the left hand side, the last term, the square term is missing. If you recall, children, you know the formula of expansion of x minus a, the whole square. What is it, children? It is x square minus 2ax plus a square. Now if you compare this expansion with the left hand side, which term is missing over there? The square term. The last term is missing. So we have to get it. In order to get the last term, what do? We compare the coefficient of the middle term with the coefficient of the middle term in the expansion. So here we get minus 2a, which is equal to the coefficient of the middle term in the given problem, that is equal to 1. Somehow if we get the value of a, then we can square it and we get the last term, which we can substitute, complete the square and get the required result. So over here finally we are left with minus a, which is equal to 1. Now 2 is performing the operation of multiplication. So when we transfer it from the other side, multiplication becomes division. So it becomes 1 upon 2. What do we do to get a square? Definitely we'll have to square this. So whatever you do on the left hand side should also be done on the right hand side. So squaring both the sides. Let me continue over here. So minus a into minus a will give you a square, which is equal to 1 upon 2 into 1 upon 2 gives you 1 upon 4. There you are. Now you get the last term, that is a square. Once you get this answer, you add it up to your left hand side and the right hand side of equation number 1. So let's continue. X square plus x plus 1 upon 4. Are we done with it? Definitely not. Whatever you do on the left hand side should also be done on the right hand side. So 20 plus 1 upon 4. The left hand side becomes a complete square. It is a complete square of which binomial, children? How do you get the answer? We have already learnt in the earlier classes. Take the square root of the square terms. So which are the square terms over here? X square and 1 upon 4. What is the square root of x square? X. What is the square root of 1 upon 4? It will be 1 upon 2. And what about the sign in between? The sign will be the sign of the middle term, that is plus. The whole square. If you expand, you again get x square plus x plus 1 upon 4. A plus b the whole square gives you a square plus 2 into a into b plus b square. Now, here children, the LCM method or the cross multiplication method, 20 into 4, that is 80 plus 1 into 1 is 1 upon 1 into 4 gives you 4. Now children, here you have a square on the left hand side along with the right hand side. So first let's solve the right hand side properly. 80 plus 1 gives you 81 upon 4. Now children, in the earlier classes you have learnt, if a square is equal to some number 4, Then how do you find out the value of a? Take the square root on both the sides. So what do you get? Square root of a square will be square root of 4. Therefore, a will be equal to plus or minus 2. Same will be implied on this problem. So we are taking the square root on both the sides. X plus 1 upon 2. Its square root will be equal to square root of 81 upon 4. Let's find out the square root now. And rub out the left hand side, children, to solve the problem further. Now, what is the square root of a square? It will only be a. What is your a over here? X plus 1 upon 2, which is equal to, now over here, it is square root of 81 upon 4. So, the square root will be plus or minus 9 upon 2. So, plus or minus 9 upon 2. Are we done with the answer? No. Finally, you have to end up only finding the value of x. So, plus half should be transferred on the other side. But over here, you see two values, children. So, let's first separate. So, you get x plus half will be plus 9 upon 2 or x plus half will be equal to minus 9 upon 2. Let's solve the first part where the value is 9 upon 2. So what do we get, children? Plus half. When it goes on the other side, minus half. The denominators are the same. So you can equate the numerators. 9 minus 1. So x will be equal to 8 upon 2. Reduce 2 ones are 2 4s are. So that finally we are done with x is equal to 4. Let's solve the other side. Plus half again goes on the other side, gives you minus half. Again over here, the denominators are luckily the same. So numerators, write them as it is. Minus 9 minus 2. So therefore, x will be equal to minus 9 minus 2 gives you minus 11 upon 2. So what are the two values of x that you get? X is equal to 4 or x is equal to minus 11 upon 2. These are the roots of the given quadratic equation. Therefore, x is equal to 4, x is equal to minus 11 upon 2 are the roots of the given equation. So which method did we use, children? We used the method of completing the square. And what condition did I tell you in the beginning? You have to be careful that the coefficient of the square term should be equal to 1. If it is not 1, then what do? We make it 1 and then proceed with the same steps. So in the next problem, we will take a coefficient other than 1. Continue with the same method by completing the square to find the roots of the given quadratic equation. 5x squared is equal to 4x plus 7. But children, mind you, if you compare this problem with the earlier one, the coefficient of the square term in the earlier one was 1 and over here you see it is 5. So the first step before we start with the following steps to continue with the problem and end it up, we will have to get rid of the coefficient of the square term. So what do we do in this case? Divide the whole equation by 5. So whatever you do on the left hand side should also be done on the right hand side. Before doing this, children, first let us put it into the general form of a quadratic equation. So how do you do it? 5x squared plus 4x becomes minus 4x when you transfer it, plus 7 becomes minus 7, which is equal to 0. Now dividing the equation by the coefficient of the square term. In this problem it is 5. So how do we do it, children? Each term divided by 5. Are you done with it? Definitely not. In an equation, you know, whatever you do on the left hand side should also be done on the right hand side. What will happen over here? Reduce. 5 ones are 5 ones are. What are you left with? X squared minus 4 upon 5x minus 7 upon 5, which is equal to 0 divided by any number is always 0. Now children, transfer the constant term on the right hand side. Now we are following the steps as the earlier problem, because now over here the coefficient of the square term is 1. So x squared minus 4 upon 5x, which is equal to 0 plus 7 upon 5. So what are you left with? X squared minus 4 upon 5x is equal to 7 upon 5. With what do we compare now? We compare with x minus a the whole square. The coefficient of the middle term of that expansion will be compared with the coefficient of the middle term of the given problem. So once again I will repeat. The expansion x minus a the whole square is equal to x square minus 2ax plus a square. So what do we compare it to? We compare minus 2a and equate it with minus 4 upon 5. Ultimately for getting the value of a square, that is the last term. So let's continue, children. Minus 2a will be equal to minus 4 upon 5. Minus on both the sides, you can get rid of them. So you are ultimately left with 2a is equal to 4 upon 5. So a will be equal to 4 upon 5. 2 is performing the operation of multiplication. When it goes on the other side, division. Let's reduce. 2 ones are, 2 twos are. Therefore, a will be equal to 2 into 1 is 2 upon 5 into 1 is 5. So this is the value of a. We require the value of the square term a squared. So what do we do on both the sides? Again, square. 2 square is 4, 5 square is 25. Now, to continue with, once you get the value of a square, what do? You add it up to your left hand side as well as right hand side, such that the left hand side becomes a complete square. So let's do it. X square minus 4 upon 5x plus the value of a square 4 upon 25. Once again I repeat, whatever you do on the left hand side should also be done on the right hand side. Now children, once you put the last term, the left hand side, as I told you, becomes a complete square. How do you find out it is a complete square of which binomial? It is a square of which binomial? So, see the square terms, x square and 4 upon 25. So, it will be x, the square root of the square terms, x. For 4 upon 25, the square root is 2 upon 5. And what about the sign? Which sign will you insert? The sign of the middle term, the whole square. So the left hand side is a complete square of x minus 2 upon 5, the whole square. On the right hand side, children, if you look at the denominators, you have 5 and 25. So you know your LCM. What is the LCM of 5 and 25? It's 25. So to make the first denominator equal to the LCM, multiply by 5. Whatever you do in the denominator should also be done in the numerator. So 7 into 5 is 35 plus you have the LCM equal to the denominator of the second term. So write the numerator as it is. So finally you have x minus 2 upon 5 the whole square, which is equal to 39 upon 25. Now children, I have told you ultimately you have to find out the value of x. So you have to first get rid of the square. So how do you compare it? Suppose this is a, then if a square is equal to 4, a will be equal to plus or minus 2. Same thing we will apply it to this problem. And about this side, children. Let's continue. So we are left with x minus 2 upon 5 the whole square is equal to 39 upon 25. So how do we get rid of this square and just get x minus 2 upon 5? So we take the square root. So if we take the square root on the left hand side, you have to take the square root also on the right hand side. So taking the square root on both the sides. Square root of 39 upon 25. So this resembles your a square. So square root of a square will just be a, which will be equal to plus or minus, if you have not forgotten. Square root of 39, it's an irrational number, so it remains as it is, upon square root of 25 is 5. Now, how do we follow the next few steps? Once with a plus, once with a minus to get the value of x. So x minus 2 upon 5 will be equal to square root of 39 upon 5, or x minus 2 upon 5 will be equal to minus root 39 upon 5. Let's solve the one with the positive value. Minus 2 upon 5 goes on the other side because finally we have to get the value of only x. So x will be equal to root of 39 upon 5. Minus 2 upon 5 becomes plus 2 upon 5. Denominators are the same. So therefore x will be equal to root 39 plus 2 upon a common denominator, that is 5. Can you add these two numbers? Definitely not. This is an irrational number. This is a rational number. So you cannot add them. You leave this as the answer. On this, what do you work out? The steps to be done. X again will be equal to minus root 39 upon 5, and minus 2 upon 5 when it goes on the other side will give you plus 2 upon 5. So children, here you are, x is equal to again the same common denominator. So in the numerator minus root 39 plus 2. So one answer is root 39 plus 2 upon 5, and the other one is minus root 39 plus 2 upon 5. So these are your roots for the given quadratic equation. So which method did we use? We used the method of completing the square. Only what did we take care in the first step, children? Let's recall. We saw that the coefficient of the square term should be 1. If it is other than 1, the same number will be divided throughout the equation to equate it to 1, and then follow the same steps to ultimately get the roots of the given quadratic equation.